1 and 3, the time constant experience, analyzing the transient time response of the type K thermocouple. This is similar to the thermocouples that we use in the instrumentations lab last year that many of y'all might have taken. A little background, we want to use a thermocouple to measure the temperature of a transient system, and we're looking, like I said, looking at the transient response time. We use a type K thermocouple, which is the most commonly used because it's good at a wide range of temperatures. It's a 1/4 inch wide thermocouple consisting of 2 junctions. And when there's a temperature difference between those 2 junctions, you experience a voltage, like current that runs through the circuit. And this gives you a current reading and it is then converted into a temperature reading. And this data, the PDAC data acquisition that we use, it actually converted the current readings itself to give you a temperature reading. I don't know if y'all remember last year or whenever you took instrumentations, you actually had to do that yourself. So that was the benefit of using this data acquisition tool. Our apparatus consisted of a flask of ice water, which was filled right before the experiment took place, which that's supposed to be around a little over 1 degree Celsius. And then you'll see in slides 3 and 4 that our thermocouple got down to about 4 degrees Celsius, which might have happened because of the operator's hand on the thermocouple or him moving it around the flask too much, creating friction between the water and the thermocouple, which would have raised the temperature. And this is our experimental setup. I made a beaker, couldn't find it online, so I had to make it myself. It's a beaker with ice water, and then this little stick right here is the thermocouple sitting in the ice water. The hardest part about doing this experiment was trying to keep the thermocouple in one spot, so that way you wouldn't have any uncertainties. But since it is humans and we will make errors, it probably moved around a little bit, so you will see uncertainties with that. Another uncertainty that you might notice in the data would be because of the thermocouple itself. All thermocouples have data charts of uncertainties associated with each individual one. The procedure was very simple. We started the data acquisition program, and then we filled the beaker with ice water. We did this right before the experiment took place in order to make sure none of the ice melted before the thermocouple was actually inserted into the beaker. And then we connected the type K thermocouples to the plug board and inserted the thermocouple into the ice water. We waited in order to check and make sure the thermocouple was working correctly. We kept it outside of the ice water first before inserting it in to see if we got that room temperature of about 22 degrees Celsius. And then once it was inserted in, you'll see on the next slide, we have the graphs. You can see it was inserted in about a minute after sitting in room temperature. And once the insertion took place, the temperature dropped down to about 7 degrees Celsius. And from here to here, which is about a minute, you can see that time transient response take place between 7 degrees Celsius and it got just below 4 degrees Celsius. And then once it got to where it wasn't changing much, we then took the thermocouple out of the ice bath, and you can see that the temperature goes all the way to about 20 degrees Celsius. The room temperature was about 22 degrees Celsius, but since after you wipe the water off, there's still going to be a little bit of cold air, I guess, surrounding it, and so it's not going to be able to get all the way up to that 22 degrees Celsius that you had before. This would take a lot longer, but because of the time that we had, we did not wait for it to get all the way up to 22 degrees Celsius. This is the log mean temperature graph. There's supposed to be an equation on here, but I left that off. But this graph looks very similar to the one before, except instead of comparing it to time, I compared it to data points, all the way to 1,461 data points. So the discussion of the results kind of highlights everything that I talked about. We had a reference temperature, room temperature of 22 degrees Celsius. Once dipped in the ice bath, you can see that it the temperature quickly decreased to about 7, and then you have that time transient response take place took about a minute that we kept it in there until it got to just below 5 degrees Celsius. And then for the exit time transient response study that we did, it was lifted out of the ice water to about 20 degrees Celsius. And I don't believe that when we did the experiment, we noted this, right? Because we weren't really looking at the procedure manual that much. So I think we might have missed out whenever we took it out of the ice water bath. I don't think we did that correctly. And then we dried the thermocouple off with a paper towel and then waited for it to reach 20 degrees Celsius.